Okay, welcome back. Now that my phone is no longer overheated, we can finish shooting the video. So if you'll recall, we left off at dA dt plus 3 over 600 minus t times a was worth 6. So this is in the format of a linear differential equation, so we can find our integrating factor. So e to the integral of 3 over 600 minus t dt. So that's e to the 3 natural log of 600 minus t. You can regroup that. E to the natural log 600 minus t quantity cubed. Ooh, got a little out of control with my parentheses there. Sorry about that. So we have my apologies to the negative third. So if we differentiate this guy, we would get the 600 over t at the bottom, or 600 minus t at the bottom. We would also have to have a -1 there, which we didn't have. So we can just kind of multiply by 1 to get the negative sign we want and still pull the 3. So raised to the -3rd power. So then our integrating factor would be 600 minus t to the -3rd power. So now all 3 pieces are going to get multiplied by 600 minus t to the -3rd. So our dA dt gets hit with that. The 3 over 600 minus ta gets hit with that. And the 6 as well. Okay, so a little bit of simplifying here. In the middle we have 600 minus t to the now -4th. So now the left-hand side is a derivative. So 600 minus t quantity to the -3rd times a. And you can always check it, just sort of mentally do that product rule. Derivative of a, keep the 600 minus t to the -3rd, keep the a, differentiate 600 minus t to the -3rd, so we'd have a -3, 600 minus t to the -4th, times the -1, which would turn that -3 back into the +3 we see. And the other side, we'll just hang on to that. So now we are ready to integrate with respect to t. So left-hand side, 600 minus t to the -3rd times a. Right-hand side, hang on to your 6. 600 minus t, we're integrating, so we will add 1 to the exponent. So we'll need a -1/2 as well as a -1 there. So differentiating this, the -1/2 times the -2 is a +1. 1 times -1 is our -1. So we have a positive 1/2 essentially there. So 1/2 by -2 is a -1. Hang on to 600 minus t, raise it to the now -3rd, so subtracting 1 from the exponent if we are differentiating, and then times the -1 inside. And then we have our plus arbitrary constant c. So a little bit of cleanup is in order. So I'll hang on to this 600 minus t to the negative third power times a for the moment. And we'll turn this into a 3 then by 600 minus t quantity to the negative second plus c. So now we can clear the 600 minus t to the negative third. So we multiply by 600 minus t to the positive third on all three terms. So then a is worth 3 by 600 minus t now to the positive first plus c times 600 minus t quantity to the positive third. All right, so then a little bit of starting information to get our C value. So we know that A of 0 was 40. We had 40 pounds of salt at the start of the experiment. So 40 is worth 3 by 600 minus 0 plus C by 600 minus 0 cubed. So 40 is worth 1800 plus 600 cubed C. Then 6 cubed, 216, so 216. And then 1, 2, 3, 4, 5, 6 zeros times C. So then we have 40 minus 1800. So negative 1760 is worth 216,000 times C. Then we'll divide both sides by 216 million, sorry. Divide by 216 million on both sides. So C is negative 1,760 divided by 216 million. And we can at least cut the trailing zeros off of there and cut it in half. So 1760. So we have negative 88. Over 108. 2, 3, 4, 5. And let's see, we can divide up both of those by 4. 2, 3, 4, 5. And dividing that by 4, we have negative 2, so we're also divisible by 2 again, so negative 11 over 135. So then our A, or A of t, whichever you want to label it as. So we can go back to our last version. We have 3 by 600 minus t minus 11 over 1,350,000 times 600 minus t quantity cubed. And you can write that with or without the 3 distributed. So you could also express the first part as 1800 minus 3t. So this is our official equation for the amount of salt with respect to time t. So in 3-1, I would recommend 1 through 27 on the odds. If you have questions, please feel free to get in touch with me. Otherwise, I will see you next time.